Hi, I'm Toby from AWS. Welcome to This Is My Architecture. I'm joined today by Gabriele from Fing. Welcome.
Thank you. How are you, Toby?
I'm very well, thanks, yeah. Gabriele, why don't you tell me a bit about Fing?
Fing is a startup that empowers people with information about their connected environment. To do so, we provide a free mobile app for a Wi-Fi scanner, a Fingbox, a sensor that you can put at home or at the office to have more awareness about your network, and an API for integration with our device recognition system as well.
So Fing is a network security solution?
It's more than a network security solution. We can provide intelligence about your network, about your bandwidth, about if you're e-space chatting, maybe.
Okay. So, for example, I could take the mobile app and run it on my home Wi-Fi network to discover which devices are attached, what type of devices they are.
Yeah, of course. It will return to you some device recognition.
Okay, great. So let's work through that example then. I see we've got the mobile here, we've got an application load balancer. Do you want to talk through that flow?
Yeah, sure. If you download the app and trigger a scan, the app will send you some fingerprinting, some metadata to the ALB. Behind the ALB, we have front ends.
So they're running on EC2. What software are you running for that front end?
We have Nginx and Tomcat for front end, and the other services are completely Java services.
Okay. So behind the front end, I see we've got a couple of components there. Do you want to walk me through what those are and what function they provide?
Yeah, sure. Behind the front end, if you trigger a scan, we have device recognition system. Front end sends some data to the device recognition system, and it returns quite immediately, let's say seconds, the device type, device brand, and device model of your connected devices. Fingbox shards are in charge of handling the Fingbox. So the onboarding is always with the ALB. But after Fingbox gets a persistent connection to the shards.
Okay, so you've got a shard there that provides for that long-running persistent connection.
Yeah. It can last even weeks, months.
Okay. And I see on the right-hand side here, we've got a Hadoop stack here. Can you tell me a bit about the function that provides within your solution here?
Yeah, sure. When you trigger a scan, front ends are in charge also to send traffic to the data VPC. Here we run mainly ETL jobs for data transformation to change the data from raw data to structured data. And we run even Spark jobs, machine learning jobs for MAC clustering, so that we can predict what device will have that MAC addresses, and we will give back to our device recognition system.
Okay, so this is working asynchronously, improving the quality of your device and accuracy of your device recognition responses.
Yeah, sure. The more data we ingest, the more accurate the device recognition will be.
And presumably you've got some kind of queuing system that sits in between the front end and your Hadoop cluster?
Yeah, sure. We have Kafka that handles the queue from front ends to Spark, and it's a point of contact between the two VPC.
Okay, great. I see we've got Aurora here. What function does that serve here?
Yeah, sure. In the Hadoop cluster, we also run Hive. Hive is an abstraction that allows you to query your HDFS with SQL-based queries. And in order to work, it needs a metastore that's it's an RDBMS, and it's based on Aurora, on a serverless Aurora, as we have an infrequent workload, so we didn't need to provision an instance.
Great. So you're using Aurora serverless here for your Hive metastore. Great. Yes. Okay. So Gabriele, I'm intrigued by the persistent connection you got here between the Fingbox and the Fingbox shard. Can you tell me a bit about the design of the Fingbox shard and some of the challenges you've had to overcome to make that work?
Yeah, sure. It's a Fingbox shard. It has been complicated to handle a persistent connection that can last weeks or months. to do so, we make some kernel fine-tuning of our Amazon Linux 2 instances. And AWS helped a lot when M5 instances went out.
Great, thank you, thank you. Well, Gabriele, thanks very much for sharing your solution with us today.
Thank you for having me.
And thanks for watching This Is My Architecture.